Welcome to Introduction to Operating Systems. Today we are going to explain and define what an operating system is, how it functions, and what components go into an operating system, and the types of operating systems are out there. So let's jump in and let's get started. First, we need to define what an operating system is. Well, there are two things that we want to talk about here. The first is that an operating system gives a user like me and like you a way to interact with our hardware. Users in and of themselves, by themselves, cannot access the CPU, the RAM, the hard drive, the printer without going through some type of software. That's what the operating system is. It provides us some way to interact with all that hardware, right? So when we start a program, it initiates the CPU and the RAM and the hard drive and all the other aspects of a computer that needs to function and produce that task that we're starting, right? So that's the first thing that an operating system does. It is a user interface to be able to access and interact with the hardware. Another one is it has basic tools that make your computer useful, right? If you didn't have an operating system on your computer, it would be a doorstop, right? A paperweight. There's not much you can really do with it without having a desktop on it. So it provides all those basic tools that get you on the internet, that is able to run programs, and allows you to do so many other things. So let's talk about some of the components of an operating system. What are all the different parts? One of the main parts, and probably the brain of it all, is the kernel. The kernel is the core of that operating system. It is what all the device drivers interact with. It manages the CPU, the memory, the storage, all other programs, everything else, the software on the motherboard and power management, does all of that kind of stuff. It is the brain of everything else. And everything else that we're going to be talking about kind of interacts with the kernel, because the kernel is the thing that truly interacts with all that hardware stuff. The second thing that you need for an operating system is some type of disk access or file system, right? A file system is how all your files and folders are organized on your system. And there is a certain method and layout that is designed for each type of operating system. Like, where do all the programs go? Where do all the device drivers go? Where do all the user files go? Right? And where is that stored on? Is that stored on the hard drive? And how is it stored on the hard drive? Where does it go on the hard drive? All that has to do with how the disks, meaning the hard drive or some type of storage device, is managed, and how everything is organized so you can find stuff when you need it, right? The third one here is input output device management. These are your devices that connect to your computer, that allow a user to put information into a computer and take information out or get some type of response or reply out from the computer. For example, the number one way in which you put information into a computer is through your keyboard, right? If you want to put in information into your web browser saying, I want to go to YouTube, then you go and you issue that command. You go to your browser and you type in youtube.com. You hit enter. You just had to input some information into your computer to do that. To start up your favorite game or something like that, you have to click on the Steam icon to get all your Steam games going, right? That is an input. The clicking of the mouse is your inputting and telling the computer to start something, right? So those are some input devices. Microphones I'm speaking in right now, that is an input device because it is sound now going into the microphone and being captured into the computer. Output devices are things that come out. Printers, right? So you want to print something, that's information coming out of a computer on paper, right? Your screen, your monitor is, anytime you type anything, your screen is usually identifying that task is happening and communicating to you that it is happening, right? So for instance, you start your Steam program to start playing your games, right? Well, how do you know that that's going to start? You have to look at your screen, and your screen is showing it out to you that it is starting. So those are your input and output devices. Finally, networking and security are the last two components of an operating system. If you want to be connected to an internet or other devices, it handles all the IP addresses and TCP and all the routing and whether data coming to your machine is meant for your machine or whether it's meant for another machine, and it manages all of that on your computer. Finally, security is a big part of your operating system as well. Encrypting data on your hard drive if needed. Setting permissions so that if you have multiple users on your computer, that each user can only access the files that they need to access. That's right. So these are the 5 components of an operating system that define an operating system. Let's dive into this a little bit more. We did talk about the kernel. We defined what that is. And it is, as I mentioned, the core. It allows the user to perform tasks. It accesses all the resources. So those input output devices that we talked about, like the keyboard and the screen and everything else, to complete those tasks, that's what the kernel does. Right? However, there's one gotcha with the kernel. The user cannot directly interact with the kernel because the kernel only understands machine language. Do you speak machine language? I guess some programmers can and do, but most people do not. So we need some type of translator. We cannot communicate with the kernel directly. This is where the shell comes in. The shell is a program that allows us as users to interact with the kernel, to give the kernel some commands, right? To be able to do some things. So, and interprets our language into machine language so the kernel can interact and then communicate with the CPU. So this is the way it kind of works. The user enters in commands into a shell, and I'll show you what a shell is here soon. And the shell then translates or interprets what you typed in and changes it and communicates it to machine language. The kernel accesses the necessary hardware and resources to complete whatever task you are trying to complete. And every operating system has a shell. Microsoft Windows has PowerShell. Hopefully you've been able to use that, play with that. Linux, we're going to be learning the bash shell. There are several shells you can actually be using, but we're going to be using bash because it is the most popular, most commonly used. Apple just recently used to use the bash shell, but they now use the Z shell on their system, on their latest Mac OS systems. So every system has a shell. And think about this. Why would Microsoft, why would Apple, and why does Linux all have these command line shells if they're not necessary or needed? So keep that in the back of your mind as we continue to discuss here, right? So how do we access the shell? How do we get to the shell so that we can actually interact with the kernel? We use a program called a terminal. A terminal is a program, a window that you open up, and inside that terminal is your shell. And within the shell, you are able to type commands and hit enter. And once you hit enter, it sends that information it translates that information and sends it to the kernel. Many times the shell is also commonly known as, or sometimes we call it as, the command line or the console. Now, one confusion is, this is a thing I hear from students all the time, is like, oh, this is DOS. This is what DOS was, and this is what DOS is. No, DOS was a completely its own operating system back in the day, right? Back in the 80s, early 90s. This is not DOS. This is a shell, a powerful tool to be able to power users use to interact with the kernel of the operating system. You could access a shell through DOS, but that was different. Just because you're typing commands into a command line doesn't mean it's DOS. So I just wanted to be able to clarify that construct. So let me show you the command line terminal. So I have one open right here. This is what it looks like. And I can type a command and hit enter, and I have just interacted with the kernel. The window here that I have, this is the terminal, right? Here, I'll put it up here in the corner. There we go. This is the terminal, this tiny little window right here, right? And inside the terminal, inside this window right here, this is the actual shell. So this is the terminal is the big window. And inside that is the shell. We will be learning Linux in this class. Does that mean that Linux doesn't have any type of graphical interface? No, it does. So let's talk about what that is and how we interact with the computer differently between a command line and a GUI and what a GUI even is, okay? The average user, as you probably know, does not get into the command line, does not get into a shell all that often. So they're used to interacting, at least on modern systems, through a graphical interface, right? Or what's also called a graphical user interface, which GUI, which we actually pronounce as GUI. The GUI is your menus, your icons, the way you click on things, way you scroll through menus to start programs. That is your GUI. It's your background. It's being able to use a mouse to click and drag and drop things. That is your GUI. I have a GUI right here. I'm running Linux, and you can see the GUI that I have right here. Look at it. I have a background. I have a mouse that moves around. I can right click. I can do different desktop settings. That opens up a window. I can change my background if I want. I can do that. Do whatever I like. I have this little kind of Mac-ish bar down here at the bottom. I can change that if I want, but that allows me to start programs. I can start a little notepad program here, which is called mousepad. So I can say hello, right? I can do all sorts of things. I can, right here, I can drag and drop files. I can grab that. I can drop that down to downloads and boom. Yep, I want that to copy over. And look, I get a little menu that pops up or a little warning that pops up that says, hey, you already have that file over there. Do you want to replace it or do you want to skip? I go, yeah, replace. And this is how the average user manages their files and folders, right? Well, in a command line or in a terminal, we don't do that. We type commands and we press enter. So those are the different ways. Now, the problem is with the GUI is they're perfectly fine, but they add these additional layers on top of our operating system, right? So we have the command line, we have the shell that talks directly to the kernel, which talks directly to the hardware. And then above that, there's all these other layers that allows us to have this graphical interface that draws a lot of resources from our system. This is why a lot of servers that need to be very efficient in running don't have graphical interfaces, right? Now in Linux, unlike Windows and Mac, you have your choice of desktop environments. We have multiple choice, right? You can choose in Windows 11. What do you got? You got the Windows 11 layout, right? You can modify it sometime with the bar, but like the taskbar or the background and things like that, right? But Windows 11 looks different than Windows 10, and really you don't have an option, right? I know there's tools out there where you can change it a little bit to Windows 10, but it's just modifying it slightly, right? Where in Linux you have completely different desktop environments, right? And that's what we call them, the graphical environments in Linux, is these desktop environments. I listed, and there are dozens of them. I've listed the top 4 that are out there that are most commonly used. We call GNOME, KDE, XFCE, and Cinnamon. And plus there are many others. The desktop environment defines the look and the feel of it, right? When you go on a Mac system, that has a different feel and look than when you go on a Windows 11 system, right? That's what I'm talking about. So let's look at these really briefly. This is GNOME. GNOME is a great modern desktop. It's stylish. It looks really slick. It kind of has, this is the menu system up here that fills the whole screen, kind of like Windows 8, right? Which people didn't like too much, but maybe you like it here for GNOME. It has Zoom and virtual desktops, has little taskbars on the side and on the bottom that you can use and things like that. This is GNOME. It's designed to do very little customization, where you don't have to change too much. Yeah, you can change the background, you can change kind of look, but really they don't want you messing with it too much. It's just like set up, good, go. All right. Then we have KDE, which is almost the complete opposite of GNOME, right? It has more kind of a Windows 7-ish type of look, but you can obviously change that to whatever you want, but it's highly customizable. Where GNOME doesn't have lots of settings, KDE has maybe too much settings, some people say, right? I like KDE. I've used it for a long time. If you want to be able to control every aspect of your system, then KDE is kind of the tool for you. But it could be overwhelming for others, right? The happy medium is XFCE. If you kind of like something that's lightweight, this can run on some very old systems and run very fast. That's another advantage of Linux, is that you can, things that Windows 10 and Windows 11 doesn't support, you can run Linux and run XFCE on it. It is kind of in between KDE and GNOME, where it has more settings and features than GNOME, but not as many as KDE. But it still can look very slick and very customizable as well. And finally, we have Cinnamon. Cinnamon kind of gives you a traditional desktop, kind of the thing that everybody's kind of used to, where you have a bar at the bottom, the start menu over in the bottom left corner, and it has a application menu where you can start your programs there, and just kind of when you think about a desktop, the average kind of look, right? If Linux has all these graphical interfaces, if the graphical interface is a great way to interact with it and it's easy to use, then why are we going to do the command line? If the GUI and the graphical interface is easier, why even look at a command line? Why is this class going to focus on the command line and having to memorize commands? And that's so hard, and that's tedious, and that's something you did back in the 80s, right? We don't have to do that anymore. Well, that's not necessarily true. Why would all these operating systems implement these into their system if those weren't going to be used or needed? So let's talk about some of the reasons for this. That not all problems can be solved in the GUI. There are system crashes where you might not have a graphical interface. There may be things you have to rebuild. They may have to be resolved that can only be resolved through the command line. So that's reason number one. The next thing is to be a power user, and we'll talk about some of what it means to be a power user here in these next few reasons, is you guys are going to be the solvers and solutions of these computer systems, right? You're going to be the ones managing them. You're not an average user. You're not a normal user. You need to be a power user, an exceptional user, to be able to do these things. Okay, and what does that mean to be a power user? Well, you can do things faster, better, quicker, and you can solve all the problems, right? The command line is incredibly fast. It is faster than the GUI, particularly for repetitive tasks. When you have to do things over and over and over and over and over again, use the command line. The other thing is you can automate things, right? You're going to be very busy as a technician, as a system administrator, as a network administrator, and you want to automate things. You don't want to have to do things by hand because it's so much slower, right? If you can automate it and make it just have the computer do all the work, that is always the better option. The other thing is many servers. So if you're going to be working with servers at all, many servers do not have GUIs or graphical interfaces. So all you're left with is the command line. Do you want to be the one person that doesn't know the command line and when you're tasked to work on a server? No. And finally, the other thing is just a cool thing. If you want to be ultra elite hacker and look like it and impress your friends, be on the command line. Let me tell you, all you have to do is just open it up and type 2 or 3 commands and people are like, whoa, this guy knows what they're doing. They're an elite hacker, right? And all you're really doing is looking at files and folders or something like that, right? But they don't know that. One thing you do need to know about the command line is there are 2 modes, at least the bash shell that we're going to be using here in this class. There is the normal user mode and there's the root or admin. Root is the equivalent to the administrator in Windows, right? So when I say root user, that's really the administrator user. In Windows, they say administrator. In Linux, we use the word root. Okay. The difference between the command prompt is, how do you know if you're a normal user or a root user? It is the prompt down here, right? So a normal user has this $sign symbol, while the root user has this little hashtag or # or whatever you want to call it there as part of the system. Depending on the system you're on, sometimes it will tell you that you're the root user or the name of your normal user, but that's not always the case. So let me demonstrate that here for you. This terminal here, as you can see, my command prompt is a $sign right there. I'm going to switch to the root user. And now look at, there is a #. Look at, my prompt here does not say that it's root, right? It's all different. It's how you customize the shell. and that does that. As the normal user, it does give me my name, Jared. That's me, right? That's my login name. And it has that $sign, and at root it has that. So now I can execute root commands. One of the things, the difference between a normal user and a root user is that the normal user can't do all the tasks on a computer, right? Because they're limited in what they can do, because they could break the system, right? If they don't know what they're doing. So that's the difference between a normal user and root user, where the root user can do anything. Yeah, they can jack up the system. They can mess it up. They can delete the whole root partition. They can corrupt the entire system if they type in a command wrong or incorrect, because they have complete control over the system, right? And they should know what they're doing. So it's for security reasons why we have the two different users, the normal user and the root user. Now, accessing the command line, we're going to talk about in another lesson. So right now, we're just going to get back to describing operating systems. But understanding a shell, a terminal, and what the command line is very important as part of because it's an integral part of an operating system. Now let's talk about some modern operating systems. There's 3 out there that most of you guys have heard about. Probably only 2 you've heard about if you've never heard of Linux before. Windows, most people should be familiar with. Developed by Microsoft, it runs on lots of different manufacturer vendor computers like Dell, HP, Asus, Lenovo, right? The operating system is closed, and we'll talk about more what that means in our history of operating systems. But it means that basically you can't make changes to Windows, meaning you can't make changes to the Windows kernel and how it works and how it functions. You get what you get, and you don't throw a fit, like I tell my kids, right? That's the way it is Windows. Windows is one size fits all. This is what you get, and you like it or you don't like it, right? Mac, very similar thing. Mac is based off Unix, which we'll talk about later. Now, one difference between Apple and Microsoft is Apple operating system only runs on Apple computers. You can't run the Apple operating system. I know there's hacks out there and Hackintoshes and things like that where you can sometimes get that to work. You have to know a lot. They usually don't work very good when you do things like that. But Apple operating system is designed to only work with Apple hardware. So Apple controls not just the operating system, which they do, but also the hardware to it. Where with Windows, they only own the operating system, and then Dell owns the hardware, right? And Dell modifies their hardware so Windows can run on it very well. So that's kind of a difference between Mac. Again, the operating system is not open, means you can't make much changes to it or anything else. Now, Linux is not owned by one company. It is overseen by something called the Linux Foundation. It was developed by a guy named Linus Torvalds, which we'll learn in another lesson here. Him and a whole community of people around the world who contribute to Linux. So there's not one company owner. The OS is open, which means you can modify it, you can change it, you can make it become whatever you want it to be. And so we'll talk more about that later. All right, let's compare modern operating systems. There are a lot of commonalities actually between Windows, Mac, and Linux. Let's talk about some of these things, right? First off, each one of those have a kernel. Windows has a kernel. Apple has a kernel, their Mac OS, and Linux has a kernel. All 3 of those kernels were programmed and developed in the C programming languages, right? That's one thing that's very common amongst all of these operating systems. Another thing is none of them are 100% secure, right? Especially not right out of the box, right? Not you buy a computer and you don't have to do any updates or anything, and it's just secure and it's going to be locked down. No hackers are going to get to it, no malwares on it. That's not the case. All of them need to be secured from malware and from vulnerabilities. Another thing that's common among them is you can run a lot of the same programs on each one of those. For instance, you can run Google Chrome on Windows, Mac, and Linux. You can run Firefox on Windows, Mac, and Linux. You can even run, Microsoft has now made Microsoft Edge for Linux and for for Mac, right? So if you really love the Edge browser, you can run it in Linux and in your Mac OS as well. All of them have easy to use graphical interfaces or GUIs, right? So all of them, if you know how to use a mouse and click on an icon to start a program, you got a good start on being able to run. Now, where the menus are, Apple kind of has their menu up at the top most of the time. Windows kind of has their application menu down at the bottom. Linux, it just depends. But for the most part, you know how to start programs in them, how to drag and drop files and things like that. Very easy to use. So a lot of commonality there. But what are some differences between these OSs, right? Well, I described some of these, right? Windows and Mac, they have a closed system. You can't go in and modify them, right? They're controlled by one company. Mac actually controls everything, right? The hardware and the software, and it's expensive. Linux is open, meaning you can change things, you can modify it, you can adapt the kernel if you want to whatever you want it to do. Anyone can change it or modify it. It's not locked down in any way. And usually 99% of the Linuxes out there are free. You can just download them and use them anytime you want. Why do people choose a certain operating system? Well, the biggest factor is cost. Linux is free. And just because it's free doesn't mean it sucks. Well, it's free. You get what you pay for. That's not necessarily true. If Linux was not very good because it was free, then would be Google using it to run their entire search engine? Would Amazon be using it to run their entire infrastructure? Would Facebook be using it as well to run their entire infrastructure? It is used at lots of big companies. Anything involving with the internet and websites and other things, Linux is usually involved in many of those times. Mac is really expensive. Windows is kind of somewhere in between. So cost sometimes is a factor as to why you will choose an operating system. Philosophy is another one. Some people are really built into the Apple philosophy, right? A few years ago, right, people would line up outside the Apple stores, right, overnight so they can get that. They just love the look and the approach, and they like, because Apple controls everything. That means everything kind of works and talks, right? If you buy everything that's Apple, all the Apple stuff works really well together, right? So people really like that type of philosophy. Some people like Linux. That's why I like Linux, is because I like that the common person can go in and make changes and make the operating system what you want it to be, instead of having one company dictate what it should be. So anyway, there's different philosophies out there. Much of this is awareness. Some people don't know there's other options. Some of you may have never heard of Linux, or maybe heard of it, but don't know what really to do with it, and heard it's just the thing and that's it, right? And you've just always used Mac, or you've always just used Windows. And so that's what you use, right? Because that's all you know. Now, if that's your approach on what you use, then how do you know that you're using what's best for you if you've only used one operating system? So think about why you choose your operating system. So this is a little bit about operating systems. Hopefully you learned a few things. Hopefully you learned about what an operating system, what it goes in, what parts and components make up an operating system, why we have different operating systems, and why you should really think about the type of operating system that you're running and if it is the best for you. I hope you've enjoyed this. I hope you learned a lot. Let me know if you have any questions, and we will see you later. Bye-bye.